Tackling climate change is everyone's responsibility, and utilities across the globe need to reduce the greenhouse gases they emit in delivering services. We have a huge opportunity to reduce emissions at wastewater treatment plants. Here, nitrous oxide, or laughing gas, is released as a byproduct in the process of biologically removing nitrogen from wastewater. With a global warming potential 310 times greater than carbon dioxide, nitrous oxide can represent more than 50% of a wastewater treatment plant's total greenhouse gas emissions, exceeding carbon dioxide and methane.
The amount of nitrous oxide emitted from a treatment plant depends on its design and operation. It is a bad news because the emissions from a treatment plant has to be quantified separately. It is a good news because it implies that we will have opportunities to reduce the emissions by optimizing the design and operation.
The challenge for the water industry is how to do this without compromising the plant function. We engaged water engineering technologies supported by SA Water to provide the industry with customised engineering services and integrated solutions. A new and innovative method was developed to measure the spatial and diurnal variations in nitrous oxide emissions. Off-gas was continuously collected from floating gas hoods that were anchored along the activated sludge plant. The captured gas was piped to a centralised and online emissions monitoring unit. A programmable controller was then used to control the cyclic opening and closing of solenoid valves to direct the gas captured from the individual hoods to the gas analyzer at short intervals. This let us record nitrous oxide measurements from each location in real time. We applied this at 2 full-scale activated sludge plants at Bolivar, South Australia's largest wastewater treatment plant. This has provided extremely reliable spatial and diurnal emissions data. For the first time, we can accurately understand and quantify our actual nitrous oxide emissions. It's the first detailed data set ever reported for the step-fed design activated sludge plant, one of the most common treatment technologies around the world. Using this data, we developed one of the world's most advanced models that incorporates all nitrous oxide production pathways. This allows water utilities around the globe to predict emissions and causes at any location at any time. Also, we can now identify emission hotspots, enabling us to target and tailor optimization and control measures, whether it will be operational or design improvements, cutting nitrous oxide emissions without compromising treatment performance.
We trialled one of these improvements. Optimization of aeration profiles showed a 30% reduction in measured emissions, in line with model prediction. It also improved plant performance, realising energy savings and improving total nitrogen removal.
This work has been scientifically validated, published in 4 high-impact publications.
And the project also serves as an excellent example showing how researchers and industry partners can work together to deliver benefits to the society.
The Intergovernmental Panel on Climate Change, a body of the United Nations made up of 195 governments, have now used this data to shape new guidelines for wastewater treatment plant emissions around the world.
We are very excited to cut our emissions and help mitigate the impact of climate change as we get on with the job of delivering world-class water services for a better life in South Australia.